Hello students, I am Ashish De. I am taking one of a subject that is digital signal processing. In my earlier video, I have discussed about Blackman window. So your syllabus is almost complete, okay, except digital signal processor, that is TMS 320C 5416 or 6713 processor, okay. And there are architecture of FPGA kit, okay. So today we actually I want to recapitulate the previous chapters. So today I want to start with discrete time signals, okay. Now, what is discrete time signal? Before going to the topic discrete time signal, you have to know what is continuous time signal. Continuous time signal, the signals that are defined for every instant of time are known as continuous time signal. Example, a sine wave. Suppose this is the signal, okay. This is time axis small t, and this is, suppose the signal is represented by x of t. So we can get the value of the signal at every instant of time. Every instant of time we are getting the value. Suppose at t1 instant the value is, the amplitude of this signal is this, and at t2 instant the amplitude of this signal is this. Again, suppose at this is tp instant, so at tp instant the amplitude of the signal is this. So we can get the amplitude at every instant of time, that is called continuous time signal. Now, what is discrete time signal? The signal that are defined at discrete instant of time are known as discrete time signal, okay. Remember this thing, discrete time signal is represented by x of n, right, x of n. So this signal can be okay. So this is basically, this is the discrete time signal, and it is converted from this signal xt, okay. So here this is called sampling period, capital T, okay. And the process by which we can convert a continuous time signal into discrete time signal is called sampling. So suppose this is continuous time signal, and this is discrete time signal. So the process to convert a continuous time signal into discrete time signal is called sampling. So the process is sampling. So what is sampling? We are just taking samples of this continuous time signal at a regular interval of time. That interval is called sampling period. So this is defined by capital T, and that is called sampling period, right, okay. Now some elementary discrete time signal, okay. As we know, first signal is unit step. Unit step signal. As we know, the amplitude of unit step signal is represented by the amplitude is 1 for unit step signal. So it will be represented by like this. So this is represented by u of n. Okay, and here the time is, for discrete time signal, the time is represented by n, that is called time index, discrete time index n. Okay, so unit step signal is defined by un equal to 1 for 0 less than equal to n less than equal to infinity, equal to 0 otherwise. So it can be represented by like this way also, n greater than equal to 0, for n greater than equal to 0, un equal to 1 for n greater than equal to 0, that will be most suitable. Okay, and it will be 0 otherwise. Okay, so it will starts from 0, 1, 2, 3, 4, 5, like this way. Okay, but the signal does not have any value for negative values of n. Okay, the amplitudes are obviously 1 since it is unit step signal. Okay, now unit ramp. Signal or sequence in a discrete time signal can be represented by a sequence also. That's why this is called unit ramp signal or unit ramp sequence. Okay, so unit ramp sequence can be represented by this is 0, 1, 2, 3, 4, like this way. Okay, and for negative values of n there are no value. Okay, so this is defined by r of n. Okay, now these are the basically graphical representation of discrete time signal. At first, before going to this signal representation, we have to know how many different types of representation of discrete time signals we have. Okay, so we have total 4 types of representation. So representation of DT signals, discrete time signal. DT signal means discrete time signal. Number 1 is graphical representation. Number 2 is functional. Number 3 is tabular. Number 4 is sequence. Okay, so at first, graphical representation of discrete time signal. Suppose a signal have the values as the values of x minus 1 equal to 1, x0 equal to 2, x1 equal to 2, x2 equal to 0.5 and x3 equal to 1.5. Okay, so that are the values given. You have to represent this signal by graphical representation. Okay, So for graphical representation, we the values of n starts from -1. Okay, so it will starts from -1, 0, 1, 2, 3, up to 3, right? At value n equal to -1, the value of this signal is 1. So suppose this is 1, this is 1, right? The amplitude of this signal is 1. Now at 0, the amplitude of this signal is 2. At 1 also it is 2. At 2, the value of this signal is 0.5. At 3, 1.5, it is 1.5. Okay, so this is n, this is xn, right? So this is the graphical representation of this signal given by this. Okay, now functional representation. Functional representation. In functional representation, this signal can be represented like this way: xn equal to 1 for n equal to -1, okay, equal to 2 for n equal to 0 and 1, equal to 0.5 for n equal to 2, 1.5 for n equal to 3. Okay, so this is the functional representation of this signal. You have to add also 0 otherwise. So this is the functional representation. Now number 3, tabular representation. This is not so this representation is not so important. Tabular representation, this is not so important. N, here is the value of xn. Okay, now the values of n are -1, 0, 1, again 2 and 3, right? Now when the value of n is -1, then the value of xn is 1. Now when 0, 2, when 1, then 2, when 2, this is 0.5, and when 3, it is 1.5. So this is the tabular representation. Okay, now sequence representation, sequence here. Number 4 is sequence. Sequence representation. In form of sequence, the signal is represented by like this in second bracket. Okay, and the values can be written by taking a comma. So here is 1, then 2, then 2.5, then 1.5. Okay, now you have to represent the 0th position of n by taking a arrow here. This is the 0th position, so here will be an arrow. This arrow represent the value of xn when the value of n equal to 0. Okay, so this is the value at n equal to -1, this is the value at n equal to 1, 2, this is 3. Okay.